Hello, welcome to Physics 103 online lecture. So in this video, I'm going to talk about the kinematics, okay? So kinematics is the, the branch of mechanics, okay? It is a branch of mechanics where you study the geometry of the motion. Geometry of motion. Okay, what I meant by that is we don't talk about the cause of the motion. Remember, cause and effect. Okay, we don't talk about the cause, meaning we don't talk about the force that causes the motion, but we just talk about the effect, meaning we talk about the geometry of the motion only. So in doing so, we need to introduce some parameters here. We talk about different parameters. Let's say we talk about distance, and we talk about displacement, right? We talk about time, we talk about velocity, we talk about speed, and we talk about acceleration. Okay, so then we try to find the relationship between them. Okay, let's say what is the relationship between distance and displacement, and how are they different? Then what is the relationship between velocity and speed? How are they different? Then what is acceleration? And after that, we'll talk about the equations of motion. Okay, equations of motion. So these are also called kinematics equation. These equations are also called kinematic equation of motion. Okay, then using those kinematic equation, we solve some problems. Then we conclude this lecture. Okay, that's my goal. Okay, so before I go to the formal definition of so distance and displacement, okay, so I'll start with a very interesting GIF. Okay, let me show you one of the GIFs. So here, if you take a look at this GIF, what happens is this guy starts from 0 meter here, goes to 2 meter, 4 meter, 6 meter, then come back to this position here, right? So in this case, what is the total moved, right? What is the total distance moved? It goes from 1 to 2 to 4 to 6, as you can see here, then come back. So which is 10 meters in total, right? So this is distance. Now I'm going to show you another GIF here. So in this case, what happens is this guy moves from 0, goes all the way to 6, then come back to the this position. Okay, so when it comes back to this position, and what is the final displacement? Final displacement is right here, which is 2 meters to the right. So here there is a main difference between this unit and this unit. Okay, what is the difference between these two? If we take a look, you have n and u and plus something else. In this case, that something else is right? The displacement is happening to the right. So this is your 0, this is right, this is left, right? So this guy does not go to the left. Okay, this guy goes to the right. So that's why we have the displacement to the right. So such quantities which are described by n and u, okay, just n and u, are called scalar quantities. Scalar quantities. But the other kinds of quantity here, as you can see, not only n and u, but also the direction, right? So n u plus direction is here. Okay, So those quantities are called vector quantities. Okay. Instead of writing left or right, simply what we can do is we can consider the right the positive and left the negative and vice versa. Okay. So there is not any rule of thumb, but if you consider right to be positive, then you have to consider left to be negative. On the other hand, if you consider left to be positive, then you have to consider right to be negative. Okay. So, but most of the time, we are so used to considering right as positive and left as negative, right? So I'll stick to that convention. Similarly, if you have an object at certain height and if it is falling, right? And you can consider the direction is downward, right? Downward. So you can consider downward direction to be negative and the upward direction to be positive, right? So it means the body is falling downward, meaning you just indicate that by negative direction. This is very similar to, not very similar, this is exactly what we do in x y axis, right? This is your x plus x, this is my minus x, this is my plus y, this is my minus y. Okay, so upward is plus direction, downward is minus direction, right side is plus direction, left side is negative direction. So you can stick with this convention, but it's not required. It's not, you don't have to. Okay, the thing is if this is positive, this has to be negative. If this is negative, this has to be positive. Okay, so it has to be opposite. That's what it matters. But we try to stick to our convention, which is this is positive, this is negative, this is positive, this is negative. Okay, this is, we try, but we can switch. Okay, we try to stick to this, but you don't have to. Sometimes we switch also. So all right, so this is with this, I'm going to move on to the next slide, and I start with the formal definition of displacement. Okay, suppose you have as you can see here in the picture, right? So the teacher is teaching, she's writing on the board. So this is her initial position. So right here, this is her initial position. This is the origin, we can call 0. So 0, this is 1.5 meter to the right, and the other distance is 3.5 meter to the right. So this is her final position. Okay, so the teacher moves from x0 to xf, right? So while moving from x0 to xf, which is x0 is initial position and xf is final position in this case. So she doesn't have to move straight like this. Okay, she might go this way, right? She might go this way too. Okay, so this is her initial position, this is her final position. This is her final position, right? So first of all, what is position? Position is where the body is at any particular time. Okay, at this time, let's say this time is t0 time, the teacher is at x0 position. At t equals tf time, the teacher is at xf position. Okay, so this is called initial position, this is called final position. Okay, so if you want to talk about distance, you have to talk about the total moved. Okay, so from here to here, all the way, you have to take everything into account. So let's say here to here 1 meter, here to here 80 centimeter, I don't know. This is 1 meter, this is 0.8 meter, and this is further 1 meter. So what is the total distance? Total distance is 2.8 meter, right? Okay, 2.8 meter. Now, here, I'm going to define displacement. Okay, displacement does not take the actual path into account. It just care about the initial and the final position. Okay, so it's the net change in position. Okay, that's what the displacement is. So in our case, what is the final position? Final position is 3.5, right? And what is our initial position? Initial position is 1.5. Okay, Then what is the net change? Net change is given by net change. Remember, change in physics is also written as delta x. Okay, change in x, which is delta x. So what is the definition of change? Is always final minus initial. Remember, final minus initial, that's the change. Okay, so it's not all the way around. It's not initial minus final. Never, never, never. Don't make this mistake. Okay, it's always final minus initial. That's the change. So what is my final location, final position here? Final position is 3.5. And what is my initial position here? 1.5. Okay, what is the total displacement here? 2 meter. Remember, displacement is vector quantity, right? So that's why we have to write either plus or minus. So the teacher moves from here to here, meaning she's moving to the right. So do you want to consider right to be positive? If that is the case, you have to write +2. But you don't have to write plus, because even though there is no plus, we understand that as positive. Okay, it's hidden there. Positive sign is hidden there. Okay, so this is the difference between distance and displacement. All right, so let's do one problem. Suppose a cyclist rides 3 kilometers west and then turns around and rides 2 kilometers east. Okay, then what is her displacement? So let's find the displacement of the cyclist. So she goes 3 kilometers west. So first of all, she got west. Let's consider right to be positive, which is east in our case, and left to be negative, right? So she's going west, meaning she's going negative. So how much? 3 kilometers. That's why her displacement before she turns around, her displacement is -3 kilometers, right? Then she turns around and rides 2 kilometers east. So first she goes 3 kilometers to the west, then she comes back 2 kilometers to the east. So then she has +2, right? It's coming to the right. That's why you have -3 here and +2 here. So how much is the total? Total is -1 kilometer. Okay, meaning she moved -1 kilometer in total. Okay, meaning her position, that's what I meant. Her position is -1 kilometer from where he started. This is where she started. Our final position is here, which is -1. This is -1 kilometer. Okay, to the left, right? So that's the displacement. But next thing you need to find is what is the distance she ride. What distance does she ride? Okay, that's the thing you need to figure out too. So what is the distance then? When you talk about distance, you don't have to take the direction into account. That's why this is simply -3 is simply +3. You just ignore the sign. And this +2 is again +2, right? Okay. So what is the total? It's 5 kilometers. That's the distance. Okay. Distance is 5 kilometers. All right. Then part C is what is the magnitude of her displacement? Meaning, what is her displacement again? Her displacement was -1, right? If you remember. So what is the magnitude of the displacement? You just ignore the negative sign. So that's the magnitude, right? So magnitude is 1 kilometer. And that negative sign signifies the direction, okay? So it has both magnitude and direction. 1 kilometer is magnitude. And if you write minus, that means that's the direction. In our case, that minus tells me that she traveled to the left. Okay, that's the thing. So we talked about distance and displacement, right? So distance is scalar quantities. Distance is scalar quantity, meaning it does not require direction, scalar, and displacement is vector quantity, so it requires direction. Okay, so next thing we are going to talk about is speed and velocity. So here one of them is scalar, the other one is vector. Okay, that you will get to know in a bit. Okay, so here while I start talking about speed and velocity, I start with the average speed. Okay, because there are other speeds too, but we're not going to talk about that in this slide. So I begin with average speed. Okay, so what is the average speed? Average speed is the distance traveled divided by total distance divided by total time. Suppose you got from here to here. Okay, so from A to B, what is the total distance traveled? Total distance traveled, let's say, I don't know, so 3 meter. Okay, the distance travel is 3 meter. So how long it took for you to travel from here to here? 2 seconds. Okay, so in 2 seconds you travel 3 meter, right? So then what is the total distance? 3. What is the total time? 2. That's your average speed, meaning average speed always takes total. Average means total. Okay, so total divided by total, that's called average speed. Okay, so how do you find the total? Total means the change, right? So from here to here, you take the, let's say this is your final point. This is my initial point. So the difference between these two is 3 meter, and that in the time scale, the difference between this is 2 seconds, right? So it's a total divided by total. Okay, so that's how you find the average speed. Similarly, we are going to talk about the average velocity also. Okay, so in the case of average speed, you have distance over elapsed time, but in the case of average velocity, rather, you change this distance by displacement. Okay, so the bottom remains same. So that's the average velocity. And what is the unit of those quantities? The velocity and speed. The unit is meter per second, which is m over s, right? Meter per second in SI. Okay, in this course we talk about SI unit most of, almost all the time. Okay, so that's why we have to be very familiar with SI unit. Now the one difference between speed and velocity is that this is just written as meter per second, but here this is written as meter per second plus also you have to indicate the direction. Okay, so that direction either will be plus or minus. Okay, so instead of writing plus or minus, let's say you are moving from here to here. Okay, if you don't like plus, you can simply erase that and write right. Okay, so if you are moving to the left, if you don't like this negative sign, you can simply write left. Okay, it doesn't matter, but for simplicity you can simply introduce plus and minus there. Okay, that's the thing. All right, so let's do one problem here. So a cyclist rides 3 kilometers west in 10 minutes and then returns, turns around and rides 2 kilometers east in 7 minutes. It's the same problem, but we have the time given here. Same as before. Remember in the previous slide, we had the same problem, but we have here the time also. Okay, not only the distance, we have also time. So now we need to find her speed and also her velocity. Okay, so in this case, what is her speed? What is the total distance? Total distance is 3 kilometers. We have to find the distance, right? So when you talk about distance, you don't have to take the sign into account. That's the good news. So it's 3 plus 2. That's all. So 5. So 5 kilometers is the total distance. So Now I want to change my 5 kilometer to meter. How do you change your kilometer to meter? 5 times 1000 meter, right? Which is 5000. Okay, that's my distance. Then what is elapsed time? So here you have 10 minutes, here you have 7 minutes. So how much is the total? 10 plus 7, 17. Then how do you change your minute to second? 60, right? If you do that, you will get, I have the number here, 4.9 meter per second. Okay, that's what you get. Now, how do you find the average velocity? Now, in this case, displacement, right? Now you have to take the sign into account. So you cannot simply write plus here. This is minus because this is the west. Look at that, west. That's why this is minus 3. Instead of 5, you have negative 1 kilometer. So what is negative 1? Negative 1 is negative 1, which is negative 1000 meter. Okay, that's what we have here, negative 1000. Okay, then you have time, which is the same time, right? Which is 17 times 60. Okay, so what is that again? If you divide that, I have the number here, 0.98 meter per second. Instead of writing negative, you can write 0.9 meter per second, 0.98 meter per second to left, or in our case, left is west, right? To west. Okay, you have two ways of writing this answer, either this, or instead of writing west, you can simply say minus. Okay, so either or, this is how you do the problem. Okay, make sure, remember, we did change our system to SI system because kilometer to meter, right? Meter, remember, MKS, meter kilogram second. We want to have our unit converted to MKS. So we have kilometer to meter. This is what I did. And also time in second. Okay, we are trying to do the problem in MKS. Okay, next thing I want to introduce here is instantaneous speed and velocity. Okay, instantaneous speed and velocity. In the previous slide, we talked about average, remember? We talked about average speed and velocity. Now we talk about instantaneous speed and velocity. So what is instantaneous velocity? So it is kind of average velocity at particular time. Okay, so when I said average, we talk about from here to here. Let's say A to B, right? So you talk about if the distance is 3 meters here and time taken is 2 seconds, then what is the average velocity? I should have said displacement, because when I talk about velocity, I should say displacement. 3 meter displacement, right? So 3 meter displacement over time, right? Displacement over time. Displacement is 3 and time is 2. Okay, so but if you talk about the average velocity at a specific instant in time, meaning suppose this is 3 meters away, right? A and B, they are 3 meters away from each other. Instead, they are like, very close to each other. They're almost same, right? So meaning your B is right here now. Your B is right here. Meaning you are talking about, it is kind of average velocity, but you are just talking about right at A point. Okay, because B is very close to it. So instantaneous means it's the average velocity. It's kind of average because you take this small displacement here. It's kind of average in that sense, but basically you are trying to do the velocity at a specific instant in time, which is A. Okay, so that kind of velocity is called instantaneous velocity. Similarly, what is instantaneous speed? Instantaneous speed is the average speed at a specific instant in time. Okay, so it's the yeah, it's the average speed, meaning it's just the distance over time in this case. Okay, distance over time. Here you have displacement over time, you have distance over time. So one very good example of instantaneous speed is the speedometer in your car, right? Everybody drive car, you drive car, right? That is speedometer in the car. And if you press the accelerator, what happens is your speedometer, you know, shows higher speed, right? Okay, meaning your speedometer gives you the speed instantly. Okay, you don't have to wait 2 seconds like here. Look at this to find the average, right? 3 meter 2 seconds, right? So you don't have to wait 3 minutes, 2 seconds to find the speed in your speedometer. Okay, just instantaneously, it gives the speed instantaneously. That's the instantaneous speed of the car. Okay, so all right, so you might have been in this situation. Your police, the police sometimes give you a ticket based on the instantaneous velocity. Okay, so meaning your instantaneous velocity should not be more than 65 kilometer per mile, mile per hour, right? It's like that. If your instantaneous speed is more than 65 mile per hour, let's say, I don't know, but if you exceed the limit, then you get the ticket. Okay, so all right, so let's do one problem here. Okay, so in this case, I'm going to find the distance run by a jogger. Okay, so how far does a jogger run in 1.5 hours? So what is a 1.5 hours? 1 hour. 1 hour is how much? 1.5 hour. How do you change your 1.5 hour to second? How do you change it to second? Right? So 1.5 hour. So you have to cancel your hour to change your hour to minute, right? So 1 hour 60, oops, hour should be canceled. So 60 minutes over 1 hour, remember? Then again, you have to convert your minute to second. So 60 second to minute, 1 minute. See, chain rule, right? Chain, remember? This is the chain. So minute, minute, hour, hour. So if you multiply 1.5 by 60, then you will get this many second. Okay. So how far does a jogger run in 1.5 hour or this many second? If his speed is 2.2 meter per second. Okay. Here you don't have to change this unit because you are given in meter per second. Okay. Remember MKS. You want to do the problem in MKS. Meter second is there. Meter second is there. If you have hour, you have to change it to second. Okay. All right. So what is the average distance? What is the distance run by the jogger? So the average speed, right? So average speed is this. Okay. So what is the formula for average speed? Average speed equals distance over elapsed time, right? From the previous slide. Now, what is your distance then? If you multiply both sides by elapsed time, then what do you get? Elapsed time. Elapsed time on both sides. Then what do you get? This cancel out. Then you get distance equals distance equals elapsed times multiplied by average speed. Makes sense? Okay. So then elapsed time is how much? 54, right? 5400 second. And your average speed is 2.22 meter per second. So I did not write the unit here because I know what is the unit of distance, which is meter, right? So if you do that, you will end up getting 12,000 meter. Okay. Even though you keep writing unit here, yes, and meter per second, right? You end up getting meter, see? So as long as you have you know the final unit of the distance, right? In this case, you don't have to keep writing the unit here. Okay, if you want, you can, but I'm not doing that. Okay, I just do the number here and I write the number with unit at the end because I know what is the unit of D, right? Which is meter. Okay. Okay, let's do one more problem here. If you drive to a store and return home in half an hour and your car's odometer shows the total distance traveled was 6 kilometers, then what is the average speed and what is the average velocity? You need to figure out average speed and average velocity. Okay, let's figure that out. So what is the average speed? Distance over elapsed time, right? So what is the total distance in this case? So total distance travel was 6 kilometers because you go from home to store. You say 3 kilometers here and come back 3 kilometers, which is 6 kilometers. Total distance is 6 kilometers. So which is, remember MKS, right? So change it to meter. Kilometer, change it to meter. How do you do that? 6,000, right? Meter. That's the distance. What is the elapsed time? Elapsed time is 30 minutes, right? Half an hour, 30 minutes. So 30 minutes, which is, how much is that? 30 times 60, right? So 1800 second. All right, 1800 second. Okay, so that's your, you can simplify this, that's your answer. Okay, then what is the average velocity? Average velocity is displacement over elapsed time. First of all, let's find the displacement. He drives to store and comes back home. So displacement is change in position. Remember, is there any change in position? Because he left home and came back home. It's the same place. There is no change in position. Okay, so that's why displacement is 0. You have 0 over 1800, which is 0. Okay, meter per second. So, all right. Okay, now based on the data here, this is the same data I got from the previous slide. So based on this data, I'm going to plot the graph. Okay, I'm going to teach you the graph of velocity versus time. Okay, and that kind of stuff. So I'm going to plot the graph, but to plot the graph, you need data, right? So suppose you are at home, and at that time, what is the time? It's a 0, right? It's the beginning, 0, 0 minute, right? Okay. Remember, you take 30 minutes, right, in total. Then 0 minute is 0 hour. I'm trying to do here in kilometer per hour. Okay. So then distance is in the beginning, distance is 0, right? There is no distance traveled. The similar displacement is 0. Speed is 0. Velocity is 0. Everything is 0 in the beginning. Okay. I'm trying to make the interval of 5 minutes. Okay. Every 5 minutes. So she goes from here to 5 minutes, 5 minutes here, then 10 minutes she goes here. Oops, I should have made like this: 5 minutes, 10 minutes, 15 minutes, right? Then 20 minutes, then 25 minutes, 30 minutes. There. Okay, 0, 5, 10, 15, 20, 25, and 30. Okay. So in the 5 minute, what is the 5 minute? 5 minute is hour, right? How do you find, how do you change your 5 minute to hour? 5 minute to hour, which is 5 minute. You have to cancel the minute, right? So meaning, what do? You have to cancel minute. What is the minute and hour? 61 hour over 60 minute, right? Minute and minute cancel. If you divide 5 by 60, you end up getting this here, this thing. That's what I meant. So this is how I change my minute to hour. Similarly, 10 minutes is this many hour, 15 minutes this many hour, this is this many hour, this is this many hour, and 30 minutes is obviously 0.5 hour, right? Half hour. Then what is the distance travel in 5 minutes? If the distance travel in 15 minutes is 3 kilometer, then in 5 minutes she travel 1 kilometer. Next 5 minutes, which is 10, she travels the distance total of 2 kilometer. Then 15 minutes, obviously 3 kilometer, right? Then in 20 minutes, obviously she travels 4 kilometer. She's here now, come back, right? She's coming back. Then 25 minutes, she's coming here, from here to here, which is 5 kilometer. And then half an hour she's finally here, which is total of 3 plus 3, which is 6 kilometer. Okay, but how about the displacement? Okay, in 5 kilometer your displacement is 1, right? Plus 1, right? She's going to the, this direction is plus now, this direction is minus. Okay, so she is going to 5 minutes, she's traveling 1 kilometer here, from here to here. Okay, this is 1. In 10 minutes you have 2 kilometer here. In 15 minutes she has 3 kilometer to the right. Sorry, I should have done here. Okay, then in the 20 she traveled here. Okay, so meaning from here to here is -2, meaning she's coming to the left now. So -2, then -1 and 0. Okay, this is the displacement. Then based on this data, what is the speed? Speed is this divided by, speed is this divided by this, right? That's the speed here. This gives you 12. Then similarly, if you divide this by that, you again get 12. Again, this is kilometer per hour. Okay, similarly, if you divide this by this, you get 12 kilometer per hour. This by this, you get again the same. This by this, you get same. This by this, you get again the 12. Okay, so how about the displacement? How about the velocity here? Velocity here is up to here is same, like up to here is same as speed. Okay, but what happens here now? She's okay, she's traveling -2. That's why you have a -12 kilometer per hour. So from here to here is -12. Okay, so that's the difference between speed and velocity. Now we use this data and plot the graph. Okay, let's use this data and plot the graph. All right, so we'll have the graph of position versus time. What is the position versus time graph? This is my position, this is my time. Time is 0, 5, 10. You know, you can change it to hour. 0, you know, just let's write it 0 0.1, 0 0.2, 0 0.3 up to 0. This is 0 0.4, this is 0 0.5 and 0 0.6, right? You have all the way to 0 0.6, right? 0 0.5, not 0 0.6, 0 0.5. This is the last one, right? Okay, so here up to 0 0.25, she is going up. Okay, 0 0.25, 15 minutes, remember. Here, up to here, she is going up, like this. Position is going up. So this is like 1 kilometer, this is 2 kilometers, this is 3 kilometers. So at 0 0.25, she reaches 3 kilometers here. This is 3 to 1 kilometer. Okay, then after that she comes down like this. This is position versus this is time graph. Okay, now let's do the speed. Okay, how about the speed? Speed versus time. Time, the same thing again, right? Now this is speed. If the y-axis is speed, how does the speed change? Okay, the speed is always 12, 12, 12, 12. So 1, 2, 3, 4, 5, 6, all the way to 12. Here is 12. So then the speed is same all the time. Look at that. All the way. Okay, let's do the velocity. Okay, for the velocity, let me change this scale because I have the negative also. Okay, make sure I have enough space. Okay, let me start with this guy. Let me erase this too. So this is my time scale. So this is my, this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. So first up to 0 0.25 right here. Okay, so she has 12. Look at that. She has 12 here. You know, 5, 10, maybe this is 12. Okay, she has 12 all the way. It's the same thing up to here. Oops, not up to there, here, right here, right? Up to here is 12. Okay, then after that, what happens is it suddenly goes to negative 12. So you have to go down here now, negative 12. So from here, it suddenly goes to negative, like this. This is the graph of velocity versus time. So we have three graphs. Let me show you all of them together. This is your position versus time graph. This is your speed versus time graph. Okay, this is your velocity versus time graph. Okay. Okay, now we'll talk about the acceleration here. So acceleration, when there is change in velocity, then we need to define another quantity called acceleration. Okay, meaning acceleration is related to change in velocity. Change in velocity. Okay, change in velocity. All right, so here you can see the example here. The again, let me define the direction first. The left side is minus, right side is plus. And at time t0 equals, I don't know, this is 5 seconds, right? This is 5 seconds. You start with 5 seconds. This is your t0. Then you end up 25 seconds. Meaning what is the total time here? Total time is 25 minus 5 equals 20 seconds. Okay. So during this 20-second time interval, what is happening here? Let's see. The airplane is about to fly, right? It's trying to take off. So it starts at time t equals 5 seconds. Okay. At t equals 5 seconds, the velocity is v0. At t equals 25 seconds, right? T equals 25 seconds, the velocity is v. See, different from v0. This is v0, this is v. Now, what happens if, at the time of takeoff? What does the airplane do? What happens to speed? Do you remember this? The airplane, you know, the speed becomes the airplane, you know, moves faster and faster. Do you agree? Faster and faster. What do I mean by that? Faster and faster means the velocity changes. Okay, velocity is not uniform. Is not uniform. Meaning the velocity changes. Okay. Okay, there is change in velocity. When there is change in velocity, you can define the acceleration. In this case, so the airplane is taxiing, right? You can say taxiing maybe. Okay, so at the time of takeoff, so the velocity changes, right? From here to here, because it moves faster and faster. Meaning there is change in velocity. That's what I'm trying to say. Change means positive change, means faster, not slower. Okay, it's not getting slower. So this is time of takeoff. Okay, when it lands, other, the velocity, the speed, decreases, right? There is also change, but right now I'm talking about positive change is increasing. Okay, so acceleration can be defined in any change. Okay, positive change, negative change, any kind of change, you can define the acceleration. Okay, the formula is same. This is the formula for the acceleration, meaning what is the final velocity right here. I can call it bf now. Bf is b in this case, right? What is my initial velocity? v0. v0. What is the time taken? This is my tf, this is my t0, right? Tf minus t0 is the time taken. If you divide these two quantities, you end up getting a quantity that's called acceleration. In this case, by the way, it's called average acceleration. You know why it's called average acceleration? Because you are just taking the total velocity change, okay, divided by total time. Okay, so you just take the velocity right here and right here. Okay, the total change. Okay, so that's why this is called average acceleration. All right. Okay, this is an example. We have the velocity v0 equals 0 meter per second, as you can see here, and time is 0 second, right? So v0 equals 0 meter per second and t0 equals 0 second, right? And the velocity goes on increasing, and at this point velocity becomes 260 kilometer per hour. Okay, so what is now, see this kilometer per hour, we have to change it to m, this into second, right? mks, remember, mks. So this is meter and second. So that's why let's change 260. How do you change your kilometer to meter? 1000 meter divided by hour, so 60 minute, right? And you have to change minute to second, which is 60 second, which is this. So which is, if you do that, you get 72.2 meter per second. Okay, that's my bf. So now let's plug this in. So a equals bf minus v0. What is bf? Bf is 72.2, v0 is 0, right? As you can see, v0 is 0. So this guy then divide by tf is 29 minus, what is your t0? It's 0, right? So if you do that, you got 2.49, which is close to 2.5. Okay, what is the unit again? Meter per second square. That's the unit of acceleration. Okay, this is the positive acceleration. As you can see, this is positive acceleration. So what happens if the airplane is landing here? If the airplane lands, let's say your v0 is 260 kilometer per hour and bf is 0 meter per second. Finally, it comes to rest, right? And in the beginning, your t is 0. Finally, tf equals 29 seconds, right? Then what happens? What is the velocity? Acceleration, sorry. Average acceleration is bf is 0 minus v0 is 260. How much did you have before? You had 72.22, right? 22 divided by 29 minus 0, which happens to be minus 2.5 meter per second. Okay, so in this case, your velocity goes on decreasing. That's why you got negative acceleration. Okay, so we have an example here. So it is the example from the previous slide. So if you drive to a store with an average velocity of 12 kilometers per hour and stop at the store, meaning you drive from here starting 12 kilometers per hour, right? And you stop at the store. What is the velocity then? 0, right? So it means the initial velocity is 12 kilometers per hour. Then what is the final velocity? final velocity is 0 kilometer per hour because it stops, right? Okay. Then what is the acceleration? Acceleration is given by this formula, Vf minus V0 over Tf minus T0. That's the acceleration. So what is the Vf here? Vf is 0, right? What is my V0? Vf is 0, V0 is 12, minus 12. What is my Tf? So when it reaches here, it takes 15 minutes, right? So 15 minutes meaning 0.25 hour, right? So I'm trying to do this in hour, okay? So this means what do you get? If you divide that, you get negative 48 kilometer per hour squared. Okay, if you want, you can change this to, how to change it to meter per second square, right? You can do that too. Now, this is an example where your velocity is positive, right? See, this is 12 kilometer per hour, but still your acceleration can be negative. That's the thing, okay? All right, so now I'm going to do the similar problem, but with velocity is negative, but acceleration can be positive, okay? How come velocity is negative and acceleration is positive? So how is that possible? That's what I meant. So that is possible, and I'm going to show you here how. Now, if you drive from store with an average velocity of 12 kilometer per hour, from here you start with 12 kilometer per hour, right? It means you are coming back, so which is negative, right? If you consider this as positive, this should be negative. I hope that makes sense. So this is negative 12. Your V0 is negative 12 kilometer per hour, and your Vf is 0 kilometer per hour. How do I know that? Because you stop at home, okay? So then what is the acceleration? Acceleration is the same formula again, Vf minus V0 over T sub f minus T sub 0, which is Vf is negative, sorry, 0, and V0 is, okay, negative 12, right? Negative 12. Look at that. Then divide by Tf is 0.25. How do I know that? Because it takes 15 minutes, right? Okay, how do you change your 15 minutes to hour? I'm trying to do everything in kilometer per hour, okay? So since you have it hour here, that's why you have to change your minute to hour, okay? So you have to be consistent with the unit, remember? So 15 minutes, so 15 minutes, right? And the hour, right? So how do you change it to hour? 1 hour over 60 minutes. So minute cancel out. Look at that, 15 over 60. So how much do you get? If you do that, you get 0.25. Okay, so this is the second, sorry, hour. This is the hour, okay, 0.25 hour. So then if you divide that, then the minus minus become plus, right? So which is plus 48 kilometer per hour square. Again, if you want, you can change this to meter per second squared. Okay, you know how to do that. So the regular process. So this is the example where your velocity is negative, but still the acceleration can be positive, right? So that's what I wanted you to do. I wanted to show you. All right. So here we are going to do the similar problem again. So let's read the question here. If you drive to a store with an average velocity of 12 kilometer per hour, find the average acceleration between 5 to 10 minutes. I don't know, 5 to 10 minutes here, okay, somewhere. So this is 5 minutes. Let's say this is 10 minutes, right? So between 5 to 10 minutes, meaning let's say these are the 2 points. Okay. So, or you can see here, you have the velocity versus time graph, right? Average velocity of 12. So here to here, maybe. I don't know, right? So if you drive to a store with average velocity of 12, so here is the 12, here is the 12, okay? At 5, you have 12, at 10, you have 12. So this is your VF, this is your V0. So what is your VF? VF is 12. Then what is your V0? V0 is 12. So V0 is 12 kilometer per hour. is yeah, and VF is also 12 kilometer per hour, meaning at 5 minutes you have 12, at VF you have 12. See, you have similar height, same height. Okay, 12 12. If this is 12 tall, this is also 12 tall, right? See the tall, this is the height, right? Okay, so then what is your acceleration now in this case? Your acceleration is A equals BF is 12 minus B0 is 12. 12 minus 12, so TF is 10 minus T0 is 5. So whatever on the bottom is, so your top is 0. That's why 0, kilometer on, per hour square. So that's your acceleration. So this is the example where your velocity is positive, but acceleration can be 0. Okay, this is the example. All right, so next thing we are going to learn here is constant velocity versus constant acceleration. What is constant velocity and what is constant acceleration? Okay, we are going to learn about that. Okay, so what is constant velocity? First of all, let's learn about constant velocity. So meaning, so for during the equal interval of time, the distance cover displacement is same. So look at the every steps here. Okay, so each of the steps here are same, meaning look at the distance between 2 points. That's what I meant. So look at the distance between 2 points. This is the distance between 2 points, right? Okay, so compare the distance between any 2 points, right? They are same. Okay, and time to travel, time taken by that object to travel from 2 points, any 2 points is same. Okay, at the same time it covers the same displacement, same time, same displacement. Okay, so any 2 points, take any 2 points, okay, that displacement is same and time is same. So suppose this is 1 meter and it takes 1 second to go from here to here. Similarly, this is 1 meter and it takes 1 second to go from here to here. Okay, so if the same displacement is covered in same time interval, then the velocity is called constant velocity. Okay, so now if you plot the graph of position versus time graph and the velocity is constant, what happens is your position, let's say your position is going from here 0, right? 0 to, I don't know, it's maybe how much is there? Maybe almost 200, right? 201, near to 200. Look at that. This is the position. It goes from 0 to that position. Okay, goes on increasing, right? See the distance increases, right? That's why as a function of time, the position increases. Okay, that's why the graph looks like this. Looks like this. Now, what is the velocity? Because at the same time interval, the displacement is same. That's why velocity is constant. So in our case, the velocity is somewhere between 10 and 20. Look at that, it's constant. Velocity graph is always constant here. Look at that. Look at that, the red curve. All right, so how about the acceleration here? Acceleration is 0. Why is that? Because acceleration is given by BF minus B0 divided by TF minus T0, right? So what is my BF minus B0? Take any points here. What is my BF? BF is about 10, right? And B0 is also any 2 points. So this is your F, this is your I, let's say, right? So 10 minus 10, which is 0. That's why acceleration is 0 throughout. Any 2 points, take any 2 points and do the calculation, you get 0 everywhere. That's why in this case, acceleration is 0. Okay. All right. So hope it makes sense. Now let's talk about constant acceleration. Okay, constant acceleration. In this case, what happens is at the same time interval you have different displacement. So between 0 to 1 second you have a small displacement, 1 to 2 you have longer displacement, you have 2 to 3 you have longer displacement, 3 to 4 second you have longer displacement, 4 to 5 you have longer, even longer. See, longer and longer and longer and longer, right? If you can see, if you see the dots here, the displacement become longer and longer as you go, right? So that's why at the same time interval, so this is 1 second, each interval is 1 second interval, right? 1 second, 4 to 5, 5 to 6, 1 second. For each 1 second, the displacement is different. Displacement is different for same time interval. That in that case, you say the acceleration is you say the velocity is not constant. Okay, velocity is not constant in that case. So since displacement is different for same time interval, velocity is not constant. If the velocity is not constant, okay, so then what is the acceleration? Acceleration is bf minus v0, tf minus t0. So since these are not same, constant, they are not same, right? They are not constant. So bf not equal to v0. It means this is not 0, meaning in that case, acceleration is not 0, okay? So acceleration is non-zero in this case. All right, let's see how the position versus time graph, velocity versus time graph, and acceleration versus time graph look like in this case, okay? So position versus time graph looks like, unlike in the previous example, we had like a straight line, but in this case, it's not a straight line. It's like parabola, right? Like this, okay? And how about velocity? In the previous graph, we had a constant velocity like this, remember? Now the velocity is not constant, it's going increasing, okay? It goes on increasing. Since the velocity goes on increasing, we have acceleration, which is not 0. But in this case, acceleration is not 0, but acceleration is constant. Look at that. It's between 0 to 2, maybe 1.9, I don't know. Your acceleration is constant throughout. Velocity is not constant, but acceleration is constant, okay? So meaning between, so this change in velocity, so this change, so what is the change here? Let's say your velocity here is 10, your velocity here is 8 meter per second. This is 10 meter per second. The velocity here is, let's say, 12 meter per second. Velocity here is 14 meter per second. You can see the velocity goes on increasing, 8, 10, 12, 14, right? Then what is the acceleration here? If you, based on this data, if you find the acceleration, what do you get? The acceleration is 10 minus 8 divided by, this is the time, 1 second, right? So simply 1. So what do you get? 2 meter per second square. Similarly here, what is the acceleration in this? If you take this data and find the acceleration, what do you get? 14 minus 12. And what is the time taken? 1. So which is 2 meter per second square again. See, acceleration is constant, 2 meter per second square, 2 meter per second square, okay? So acceleration is constant, while velocity goes on increasing. So this is the case, okay? When the acceleration is constant, it is constant acceleration, right? So obviously, okay. Let's see. Now I have given you this graph now. So I gave you this graph. Based on this graph, can you answer those questions? Okay, that's what I want you to do here. This is the example where I gave you three graphs: position versus time, velocity versus time, and acceleration versus time. Okay, so let's answer all those questions. What is the displacement at 5 seconds? So this is 15 seconds, right? This is 10 seconds, this is 5 seconds. So this is 5, right? So here. So how much is this? I don't know, maybe 35, okay, meter, right? This is in meter, right? Position is in meter. So what is the displacement at 10 seconds? Displacement at 10 seconds. Let's see, 10 is here. And the height is this much. How much is this? Maybe, I don't know, 80 meter, okay? So you should be able to read the graph, okay? That's what I'm trying to show you. What is the velocity at 10 seconds? So what is the 10 second here? This is the 10 second, right? Velocity graph. So here you have, how much is the velocity? I don't know, something like slightly more than 15, because 10 and 20, right? So this is, I don't know, maybe 16 meter per second, okay? Then similarly, what is the velocity at 15 second? 15 second velocity is here, right? So I don't know, this is maybe 22 meter per second. Then what is the acceleration at 5 seconds? Acceleration at 5 seconds is, I don't know, 1.9, maybe 1.9 meter per second, because it's slightly less than 2, remember? Okay, so acceleration at any time is 1.9 because it is constant. Look at this, the height is constant, okay? That's why acceleration is constant in this case, and 1.9 meter per second squared. So, but when I give you the graph in the exam, I will give you the clear graph, because you know it's like confusing here. Let's say this is the case, right? What is the velocity as 15 seconds? Well, we cannot read the number here, right? I said 22, but how about you could say 23 also, right? So I don't give you this kind of confusion, so that you know I want to make sure you can read this properly. Okay, this is just an example. I hope it makes sense. All right, so in this case, what I'm going to show you here is you have a graph, and you have to read the graph, and based on that reading, you are trying to find the some quantities. Okay, so in this case, you have position versus time graph, right? And from the position versus time graph, you can find the velocity. Okay, so how do you find the velocity? Velocity is slope of this straight line, because it looks like this is a straight line in this case, right? This is a straight line. So the position versus time graph is a straight line in this case, and you can find the slope of this straight line, and that slope happens to be the velocity, average velocity. Okay, that's the beauty of this kind of graph. Position versus time graph, if you find the slope, then that happens to be average velocity. Okay, so now let's figure out the slope. So what is the slope? 2-point formula, right? Slope is m y2 minus y1 divided by x2 minus x1, right? So what is your x2? This is, let's say this is your x2 y2, x2 y2. This is my x1 y1, right? Okay, x1 is 0, y1 is 5, x2 is 5, y2 is 25. So what is the slope of this straight line based on this data? So y2, plug in the value 25, right? y1, 5. So x2 is 5, and x1 is 0. So which is 20 over 5 equals 4 meter per second. So 4, right? It's the 4. So how do I know the unit is meter per second? I wrote it there. So because the y2 minus y1, okay? y2 minus y1, 25 minus 5. So 25 minus 5. What is the unit of 25? Meter. 5 also meter, right? That's why meter minus meter, you get meter here. What is the unit of x2? 5. What is the unit of x1? Sorry, what is the unit of x2? Second. What is the unit of x1? Second. So you have second minus second, so which is second here. So meter per second, right? Meaning, if you find the slope of position versus time graph, the quantity you can obtain from there is average velocity. Okay, how? By finding the slope. Okay, so y2 minus y1 happens to be the displacement. Elapsed time is x2 minus x1, because your x-axis is time, y-axis is position. Okay, this is how you find the average velocity from the displacement versus time graph. Now, so similarly, you can find the let me try to make a very nice conclusion here. If you are given position versus time graph and find the slope, like here, then that slope gives you velocity. Look at that. That slope gives you velocity. Now, if you have the velocity versus time graph, and if you find the slope, then that gives you acceleration. Look at that. So it moves from position versus time, you get velocity. Velocity versus time, you get acceleration. How? By finding the slope. Find the slope here, and that slope becomes velocity. Find the slope here, that slope becomes acceleration. Okay? All right. Now, so on the other hand, if you have velocity versus time graph, then you can find position also. So if you have acceleration versus time graph, from there you can find velocity also. It goes both ways. You can find from here to here, you can find velocity. From here, you can find acceleration. Okay, let me, so from here, you can find velocity. Okay, from here, you can find acceleration. Okay, now, on the other hand, from here, you can find this. And from here, you can find this. Okay, so how do you find that? By looking at the area. Okay, if you, the area, suppose let me start with the acceleration versus time graph. This is the acceleration versus time graph. It is straight line like this. What is the area under that curve? That area happens to be the velocity. Okay, now similarly, if you have velocity versus time graph here and find the area, okay, that area happens to be the position or displacement. Okay, so that's the beauty of these three graphs. So you can convert one thing to the other thing. Okay, let me do an example here. Hopefully that will clarify the concept. All right, so calculating the distance on velocity time graph. So you are given velocity time graph here. Okay, so you want to find the distance travel in the first 2 seconds. Okay, meaning, so this is the velocity versus time graph. First 2 seconds, meaning this is 1 second, this is second, right, up to here. So in 2 seconds, what is the displacement? Meaning, from velocity versus time graph, you are trying to find the displacement. Okay, so displacement when t equals 2 seconds. So then you have to find, this is the velocity versus time graph, right? This guy. So now find the area under this graph. Okay, up to where? Up to 2. Then if you find the area, that gives you the distance traveled in 2 seconds. Okay, let's find the area. So what is the how do, this is the triangle, right? How do you find the area of the triangle? So the time duration is 2, right? So area of the triangle is 1/2 base times height. If you remember, that's how you find the area of the triangle. So 1/2 is 1/2. What is base? This is my base. So from here to here is 2 second, 2 second base. Then times height. How tall is the triangle? So this is 2 meter, right? 2 meter per second tall. Okay, by the way. All right. So then that gives me, if you multiply this together, then you get just 2 meter. Okay. So in this case, we are trying to find the acceleration at t equals 1 second right here. Okay. So what is the location of this point? 1, 1, right? So see, you go 1 here, you go 1 up here. So this is 1, 1. Okay. So how do you find the acceleration at t equals 1 second? You have to find the slope here, right? But to find the slope, you need 2 points, by the way, right? So then you just take the next nearest point here. Let's say this is my other point. So you know this is 1, 1, right? And this is another point. So take the nearest one. So 2, 2, right? Go 2 here and you go 2 here. That's how you reach there. So this is my x2, y2. This is my x1, y1, right? x1, y1. So how do you find the slope now? Slope is y2 minus y1 divided by x2 minus x1. y2 is 2. What is my y1? y1 is 1. So what is my x2? x2 is 2. What is my x1? x1 is 1. So you got 1/1, which is 1 meter per second square. Okay. So meaning from this velocity versus time graph, you can find the acceleration, and which happens to be 1 meter per second square. Okay. So in this case, y2 happens to be vf, y1 happens to be v0, x2 happens to be tf, and y1 happens to be t0. So exactly this matches with the acceleration. See that? This is the formula for acceleration, and your slope happens to be acceleration. We got 1 meter per second squared there. Now we are in the final step now. Okay. Now we find the equation of motion for constant acceleration in one dimension. So in this class, we will be focusing on constant acceleration and one dimension, meaning straight line. Okay. So that makes our life easy, because you know, if it is 2D, 3D, it will be little difficult. Okay. So just straight line. You don't have to worry about 2D and 3D. So straight line, 1D, and constant acceleration. So that's the that makes our life easy. So let's try to find equation of motion for constant acceleration in one dimension. Okay. As you know, what is the average velocity? Average velocity is v equals x minus x0, t minus t0, right? As you know. Then what is your average acceleration? v minus v0 over t minus t0. All right. Now in this case, if you take a look at this example here, so what is your t0? T0 is 0 second. This is the start time, and this is the finish time. And your finish time is 4.74 second. Okay, meaning this this object is moving from here to here. So it's a positive direction, right? Remember, this is positive and this guy is negative. Okay, but the thing is, our object is moving towards the positive. So from here to here is positive direction. So time taken is 4.740 second, because the initial time is 0. Okay. Then what is the total distance travel in during that time? Total distance travel is 1,609 meter, meaning it goes from here to here, and the distance is 1,609 meter, and time taken is 4.74 second. Okay. So it means your t0 is 0. Makes sense? Then your x0 is 0. We can consider this is the x0, which is 0. At t equals 0, x is 0. That makes sense. At t equals 4.74, your x is 1609. So what is your delta x then? Delta x is xf minus x0. xf is 1609, and we call this x0 is 0, right? At t equals 0, your x is 0. So that's what I meant. So that's why your delta x is this guy here. Okay. All right. So meaning your this equation is this, right? This equation is this, and in under these circumstances, when x equals x0 is 0, t0 is 0, then this is 0, this is 0, right? Okay, this guy is 0, this guy is 0, then your b average is x over t, simply this over that. Okay, so that's the thing I'm talking about. Now from here, let's figure out the average velocity. What is the average velocity? Average velocity is v equals delta x over delta t, right? What is my delta x? This is my delta x, right? X minus x0 is delta x, which is 1609. What is my delta t? From here to here is this many second, right? So 4.74. So if you do that, so how much do you get? If you do the calculation, then you get 339.5 meter per second. That's your average velocity. Okay, that's how you figure out. All right. Now I'm going to tell you something about the average velocity. Average velocity can also be found. So this is one of the formula we have to find average velocity. But the average velocity can also found by different formula. So what is that formula? Average velocity, let's say velocity here is b0, velocity here is b, simply v, right? What is the average velocity? v0 plus b over 2. Does it make sense? So you have two formula for finding average velocity. You have this formula and this formula. Both of them are average velocity, right? So let me begin from here now. So from here, what is your x? X is average velocity times t. Okay. Now if I plug this formula of average velocity right here, then what do I get? V is v0 plus b over 2 times t. Now, what is the acceleration again? Your acceleration is this. This is the average acceleration. And at t equals t0 equals 0, you happen to get simply this is 0, meaning b minus b0 over t. That's your thing. Then if you simply multiply both sides by t, what do you get? Look at that. Multiply p, this t and t cancel out. Then you are left with b minus b0 on the right and t times a on the left, right? Then from here, what is your b in this case? How do you find this b? Add b0 on both sides. Remember, algebra, right? So this and this cancel out. So you are left with b equals b0 plus at. That's what you do, okay? Now remember, in the previous slide, we had x equals, what is your x? X equals 1 over 2 b0 plus b times t, remember? So then if we plug this b from here to here, look at that, this b, then what do you get? 1 over 2 b0 plus b is b0 plus at, remember? This guy, I just plugged in there, times t. Then what do you get here? 1 over 2 b0 t, right? b0 t plus b0 t, right? This t, distribute this t here, then plus at square. There. Then 1 over 2, what is this 2 together? 2 b0 t, right? Then plus at square. Look at that. So if we distribute this 1 over 2, what do you get? 1 over 2, 2 b0 t plus 1 over 2 at square. There. Then if you do that, this 2 and 2 cancel out, then you are left with x equals, this is x, right? X equals b0 t, this guy, plus 1 over 2 at squared. So now we have two kinematics formula. This is one of them. The other one is this one. If you want to find the final velocity based on initial velocity, acceleration, and time, you can use this formula. If you want to find displacement based on initial velocity, time, and acceleration, then you can use this formula. There is one more formula. Similarly, we can find another formula, which is this. So here, this is final velocity. You see initial velocity, then 2, a acceleration, a x the displacement. Okay, so these three formula are very, very important. Okay, these are the three kinematic formula equations of motion, and in mechanics I call them three lines, 1, 2, 3 lines of Bible. These are very important. Okay, so we use them again and again and again and again and again and again. So they are very important. All right, so keep that in mind. So we have three formula. Rather, I appreciate it if you can memorize them. Okay, you don't have to, but it's very good idea because we use them a lot in this course. All right, so b equals b0 plus at, x equals b0 t plus 1 over 2 at squared, v squared equals b0 squared plus 2ax. Okay, these are called kinematic equation. All right, so let's do one problem here. So based on, we can use one of those three formulae, and the question is, object is moving with 6 meters per second when the clock starts. Okay, so in the beginning the velocity is 6 meters per second. When the clock starts means at t equals 0. Now let's say how far does it go in 8 seconds if the acceleration is 2 meters per second squared. Okay, so we need to find x. What is this x? So b0 is given. What is my b0? 6 meters per second. Initial velocity 6 meters per second. Time t0 is 0 second. What is the acceleration? A equals 2 meters per second squared. What is the final velocity? Sorry, final time? Tf equals 8. Yeah, so how do we find the x? So we have three formula. So I want to use this formula here. X equals b0 t plus 1 over 2 at squared, because I want to find x, right? So what is my b0? b0 is 6. What is my t? T means the total time, 8 minus 0. So that's my t, which is 8. Okay, plus 1 over 2. What is my a? A is plus 2. You can simply write 2 here. Then what is my t? T is 80 squared. Okay, 48 plus, this cancel out, 64. Okay, so if you add them, what do you get? So 112 meter. Okay, okay, this is the displacement you got. All right, so I'll talk about this problem solving skill in systematic way. Now this is just an example. I'll start doing more systematic way. Okay, all right, so this is let me summarize whatever we learned. Then I'll introduce you the systematic way of attacking problem. Okay, so we have 5 kinematic variables. We have displacement, which is represented by x. We have acceleration. In our case, remember, we are talking about 1D and constant acceleration. So the acceleration is constant and represented, you can denote it by A. Final velocity, so V. Initial velocity, V0, and elapsed time T. So we just need 5 variables. Okay, these are the 5 variables we'll be using again and again. Okay, So based on those 5 variables, we have how many equations? We have 3 lines of the Bible, remember? So B, what are those again? B equals B0 plus AT, X equals B0 T plus 1 over 2 AT squared, and B square equals B0 square plus 2AX, okay? So these 3 lines of the Bible, so-called, have 5 kinematic variables. That's what I'm trying to say. You have B0, B, A, T, and X, and everything else just repeats, okay? We have 5 variables, we have 3 equations, all right? So now I'm going to tell you how to how to attack the problem, or how to start solving the problem in a systematic way, okay? First of all, you have to decide which direction are to be called positive and which direction is negative. That's the first step. Next step, write down the values that are given for any of the 5 kinematic variables, okay? So you are given a question, then read the question and figure out of 5 how many variables are given to you, okay? So make sure you have at least 3 variables given to you. Out of 5, you should be given at least 3. Otherwise, you cannot solve the problem, okay? If you are given 3, let's say you are given B0, A, and T, right? Then you can find the 4th one, okay? So make sure out of 5 variables, you know at least 3 of them. In this case, these 3, then you can figure out V, okay? So these are the reasoning strategy, okay? First of all, decide the direction, which is positive, which is negative, right? So normally we do right, positive, left, negative, up, positive, down, negative. Then write down the given kinematics variables and make sure at least 3 of them are known, you know, or trying to find 3 of them. You know, if you cannot find it, just reread the question, you'll figure out, okay? All right, let's do one problem here. A spacecraft is traveling with a velocity of 3250 meter per second. So this is the initial velocity, okay? Initial velocity is, you can make a table like this because you need 5, right? X, A, V, B0, T. Then what is the initial velocity? A spacecraft is traveling with velocity this, meaning in the beginning it is traveling. That's the initial velocity. That's why 3250 meter per second is the initial velocity. Suddenly, the retro rockets are fired and the spacecraft begins to slow down with an acceleration whose magnitude is 10. So acceleration is 10 meter per second. But the thing is, the spacecraft is slowing down. Do you remember? Slowing down because acceleration is b minus b0 over t, right? So slow down, meaning the final is less. Suppose this is, you know, this b is, the final is slow, means 3000. Your initial is 3250. It means it is slowing down, right? Final is 3000, initial is 3250, slowing down. In that case, what happens to the acceleration? So less, smaller minus bigger. That's why this happens to be negative. Okay, you have to be very careful. Okay, so then what is the velocity of the spacecraft when the displacement of the aircraft is 215 kilometer? So now your displacement is 215 kilometer. How do you change it to meter? Because remember, our system is here meter per second. Meter per second is square. Now this is kilometer. No good. system consistency, right? That's why you have to change this kilometer to meter per second now. 215 times 0, 0, 0. That's how you do the meter, right? Then what are you supposed to find? Velocity, V. So out of 5, you know 3 of them. You know this, you know this, you know this. So if you know 3 of them, you can find the 4th one. You don't need this anymore because this is the thing you need to figure out. So now you need to find the formula that connects these 4. Remember we had 3 formulae. Out of these 3, which one connects these 4? These 4. Which formula connects these 4? Remember those 3 formula now. So which one is the one you need to choose? Think about it. Okay. So we have this, we have this, we have this, we have this. So B0AX. B0, we don't have X here. This is gone. B0AX. B0AX. I think this is the one we are using. Okay. No good. No good. Okay. Think about it and find the proper one. This is the one we are doing now. Okay. Now let's do the, yeah, we know the formula. This is the formula we are using. So we need to find B. Now let's plug this in. So what is my, this B square equals B0 square plus 2AX, right? Then what is your B? To find B, take the square root on both sides, right? So then this is B. On the left side, you have B. This is V. Then you have this guy here on the right. Now let's plug in the values here. So what do you get if you plug in those? Now B0 square is, help me here, 3250 square plus 2A is negative 10, right? Remember the negative sign. This is very critical. X is 215000. That's your X. Now if you do that, you get, by the way, you will have plus minus, right? I forgot plus minus here. Okay, plus minus. So then if you do that, I'm not going to do the calculation, but I'm going to give you the answer, 2500 meter per second. How come we have plus minus here? Do you understand? Suppose you have X equals 9, X squared equals 9 rather, then what is your X? X equals plus minus 3. So in this slide, we'll be talking about freely falling bodies, right? Okay. So let's consider, let me start with these two tubes here. One of them is air-filled tube, and the other one is evacuated tube. Okay. And one of them has, so both of them have rock and paper. This is rock, this is paper. This is rock, this is paper. This has no air, and this has air. Okay. So in the absence of air, what happens is these two objects, one is lighter, stone, right? A rock is heavier than the paper, right? So in the absence of air, both of them fall at the same time, provided they are released at the same time from the same height. Suppose they are released from here at the same time, both of them at the same height, and we release them at the same time, then both of them fall here at the same time, irrespective of the weight. One is lighter, the other one is heavier, paper and rock. But in this case, what happens is there is air. And in this case, even though you release them at the same height, same time, the rock descends faster. Okay. Acceleration is called acceleration due to gravity. Acceleration due to gravity. It has long name, acceleration due to gravity, and we call it G, right? our acceleration becomes g in this case. Okay, so what is the, and this acceleration happens to be constant, and what is the value of that g? 9.8 meter per second square. And what is that in English system? 32.2 feet per second square. Okay, so that's the value of acceleration due to gravity. All right, so this acceleration due to gravity is constant on the Earth's surface, right? On the surface of the Earth, the acceleration due to gravity is constant, which is 9.8 meter per second square. We can say up to the height of 10 kilometer, we can consider that to be constant. Not only on the surface, up to the height above the Earth, go all the way to 10 kilometer high. Okay, up to that height, we can consider that acceleration to be 9.8. Okay, so how high is 10 kilometer? Is the altitude of commercial jet airplane. Okay, so that's the altitude, that's the 10 kilometer. All right, so let's do some examples on free fall. Okay, so we have two examples here, then I'm done. Okay, so a freely falling stone. Now a stone is dropped from the top of a tall building. After 3 seconds of free fall, what is the displacement y of the stone? Okay, in this case, even though we are doing this on the atmosphere, we can consider that air resistance to be negligible, because as compared to the gravity, which is, you know, bigger force, the air resistance is small, which is like a drop in an ocean. Okay, so that you can safely neglect the air resistance here. So we can consider this to be free fall, kind of. Okay, so we consider the up, plus, down, minus. Okay, so the after 3 seconds of free fall, what is the displacement of the stone? Now let's figure out what are the so how do you approach this problem? So what are the given quantities here? What are the given quantities? A stone is dropped. Let me show you here. A stone is dropped from the top of the tall building. Remember, at least you have to have three quantities, right? You are given t. T is 3 seconds. So what is the displacement? You need to find y. That's not given. A stone is dropped from the top of the tall building. So what are the 5 quantities, by the way? You have y, a, b, b0, and t. In the x, we have x, y now, okay? Because it's vertical, I call it y rather, okay? That sounds more logical. So we have 5 different parameters. So out of 5, do you know y? No, that's why we need to figure out. Do you know a? A is acceleration due to gravity, okay? Remember, so acceleration due to gravity is always downward, okay? G is always downward, meaning towards the surface of the earth, okay? So your downward direction is what? Negative. That's why your z is negative 9.8 meter per second square. Keep that in mind, okay? Your a is g, which is negative 9.8 meter per second square. What is your final velocity? We don't know. What is the displacement? We need to figure that. We don't know this. But are we supposed to find? No, we are not supposed to find. So it is kind of useless here. What is V0? Do you know V0? Let's see. A stone is dropped from the top of a tall building. It is dropped, meaning your velocity is 0 in the beginning. You drop it, okay? It is dropped, meaning your initial velocity is 0 meter per second. So you have to read the question very carefully, okay? Then what is the time it takes to get to the point here, this point? Time is 3 seconds, right? Now, let's summarize this guy. So we have 9.8, 0, and 3. Let's summarize in the nice table here. Y is unknown, right? That's why I need to figure out. A is minus 9.8 meter per second square. B is, we don't care, right? This is useless to us. V0, 0 meter per second. The thing is dropped, meaning 0 meter per second. Then T, what is the T? 3 seconds. That's the thing. Now we need to find a formula that relates these four quantities, remember? Now we have these three lines of our Bible, remember? So find one of them. Now think about it. So which one is appropriate that connects these four quantities? You don't need A. So whatever you have, no, you don't need V, okay? Find the one that does not have V in your equation. You have B here because, see, this is useless, right? This is B. These two are useless. So use this one now. Okay. You have V0, T, and A and T. That gives you Y. Okay. All right. So let's do that. All right. So your equation is Y equals B0T plus 1 over 2 AT squared. Let's plug in. What is B0? 0 times T, 3 plus 1 over 2 A, negative 9.8 T squared, 3 squared, right? So this is 0 times 3, which is 0, 1 over 2, then this is minus, right? 9.8, then 9, right? If you do that, you end up getting negative 44.1 meter. So what does this negative signify? This signifies that the stone is coming down. Remember, downward is negative. That's the significance of this negative sign. Now, let's do one more problem. The referee tosses the coin up with an initial speed of 5 meters per second. In the absence of air resistance, how high does the coin go above its point of release? Okay, so why coin slows down? So you have to answer these two questions here. First of all, let's answer why coin slows down. Okay, velocity is up. What is the acceleration? Acceleration is down. Okay, so velocity and acceleration are opposite direction. That's why it slows down. Okay, this is easy to answer. All right, I did that, right? Now let's go to the main question here. So the referee tosses the coin up with an initial speed. Well, let's say, what are the parameters we need? We have 5, right? A, Y, A, V, V0, and T. What is my Y? Do you know? We don't know. That's the thing we need to figure out, right? How high does the coin go? That's the thing we need to figure out. What is your A? A is your downward is negative. Look at that. Your downward is negative, your upward is positive. Remember, your A, in this case G, is acceleration due to gravity, which is always downward, right? As I said earlier, it means it's always negative because you consider downward to be negative. Look at that. Okay, so that's why this is negative 9.8 meter per second squared. What is your B? B is plus, no, this is B0. B0, B0 is plus 5 meter per second. Then what is the B? V is final velocity. The referee tosses the coin up with an initial speed of this. In the absence of air resistance, how high does the coin go above its point of release? So how high it goes means goes up to this point. So why does this guy does not move further? This is the highest point, right? Why does this guy not move further? Because highest point, it comes to rest. So if somebody comes to rest, it cannot go further, right? That's the thing. That's why your B is 0. 0 meter per second. What is your time T? I don't think we need this. This is useless to us, okay? So out of 5, you need to have 3, remember? So we have these three things here. Out of 5, we know 3. And based on that data, we can find the fourth one, which is y. In this case, our t is useless. Does it make sense? Let's nicely write this down here. So this is my thing. Let's nicely write this down. Y equals, we don't know. A is minus 9.8 meter per second square. B is 0. I'm just rewriting from previous slide, okay? And B0 is 5 meter per second, which is plus, and T is useless, okay? Now, exclude, we have 3 formula. Out of these 3, exclude the one which has T, because that's useless, right? We know that. This is useless, this is useless. That's why we need to do this one. Remember, your X is Y, okay? That's why. Now you figure out which formula to use. This is the formula you will be using, okay? Then let's do it then. You have the formula. This is the formula you chose. Now, from here, what do you do? What is your Y? This is minus B0 square minus B0 square. This cancel out. Then what do you have on the left? B0 square minus B square. Then equals 2AY. Then divide both sides by 2A. So this cancel out. So you got Y equals this guy. So that's what I have here. Make sense? Okay. So now let's plug in the values. That's all. So what is your Y now? Y is B square is, help me here, 0 square minus B0 square, 5 square, divide by 2. Then A minus 9.8. There. If you do that, negative 25 divided by 6, 19.6, right? So this gives me 1.28 meter, right? Okay. So how do I know this is meter? Because my acceleration is meter per second square, velocity is meter per, velocity is meter per second. That's why your y, which is displacement, happens to be meter. Okay. If you want, you can keep writing the unit, but I don't want to. Okay. If you keep writing unit, then what do you have here? You have to write like this, right? You have to rewrite this 5 meter per second squared. Then this is meter per second, right? Then if you end up getting meter here, okay? So I know that, so I don't want to keep writing. If you want, feel free to do that. With that, I want to conclude this chapter. Thank you so much.